So we also lost simply the graphing part for this, I think, process dynamics and control part C. These are the graphs that we were supposed to get. I went ahead and deleted the code for that because that was in the original video that we lost. But we'll get rid of these guys. Actually, I have to run everything. There's also code from the previous parts, but we'll graph these, or we'll code these graphs as if we haven't already done those before. Because I think we did use these to copy and paste the ones that we made in in homework 5. We would have just reused the code for pasting because it's Baudet diagrams, so they all follow the same general format. So for our simulation graph, we want to do fig. This should be fig 2. Where am I? Oh, I don't want to look at the other ones. I don't want to cheat. Fig 2 equals make subplots. Fig 2 dot add scatter x equals t, y equals y. It's not supposed to look like that one. Oh shoot! Did we rename our variables? No, it should have used our it should have used our first ones. Wait, where am I? Okay. Oh, okay, here we go. I don't know what was going on with that. Yeah, this is what it is supposed to look like. And the amplitude ratios that we get, they should match up with our Baudet diagram. So fig 3 equals make subplots. Is equal to columns equal 1. Fig 3 dot add scatter. So as this shows, our x values need to be our omegas, our y values are our amplitude ratio. We already had it auto-generated. And then the next one is our phase. So fig 3 dot add scatter. And for these are, so for our amplitude ratio, both the axes should be logged, but for our phase one, we only have the x-axis log because our phase is simply our it's in degrees, so you don't want your degrees axis to be logged because that wouldn't help you. I mean, you're mainly wanting to look at where it is between 0 and 360, primarily between 0 and 180. 180 is your most valuable set point on that. Okay, want 2 rows. Okay, this should be it. Alrighty, so here's our Baudet diagram. Here is our amplitude ratio graphed as a function of omega, and then here is our phase graphed as a function of omega. So we want to see where it is at 180. 56, and then we want to see where this is at 1. So where this is at 1 should match up with our peaks on here. So it's pretty, yeah, 0.486, 0.482, so pretty close. So I think that should cover the little snippet that was missing on homework for Part C. So, Carlos, thank you for pointing that out and allowing me to redo this.